Today we're going to review slope of a line and rate of change, which is chapter 2, section 2. So as you may recall, slope is the ratio of the change in y to the change in x. And so we have a number of different ways that we refer to slope. We have rise over run, change in y over change in x, and then you can see it pictorially. Change in y over change in x. And sometimes the symbol we use to represent change is a delta symbol. So we could have delta y over delta x. All right, let's start right in with an application problem since you are pretty familiar with finding slope. So we have a ladder leaning against the side of a building, and it's asking you to find the slope of the ladder. And so in this case, it's change in y, which is up 15, and change in x, which is over horizontally 5. And so 5 divided into 15 would give us a slope of 3. As you may recall also, slope is represented by the letter m, and so the slope formula for given 2 points, if you wanted to find the slope, this should be a y2. So you'll want to make that correction on your notes. It should be a y2, y sub 2. All right, so we're going to go ahead and try a problem using the slope formula. You could also graph these 2 points and then vertical change, and then you would find the horizontal change or change in x. Okay, so if we're using the formula, one trick that I usually like to do is to identify x1, y1, and x2, y2. So I like to mark them so that way if I'm using the formula, I can just go ahead and plug them in. So then my slope is equal to y2 minus y1 and x2 minus x1. And then of course I have a negative 2 minus negative 1, which would be 3, and 7 minus 1, which would be 6. And I could leave my answer as 3, 6, or I could rewrite in simplest form as m equals 1/2. Okay, so I'd like you to pause the video and complete numbers 2, 3, and 4 using the formula, and or you could use a piece of scrap graph paper to graph them and count your vertical change versus your horizontal change. Okay, welcome back. So hopefully you were able to find the slope for number 2, number 3, and number 4, and we'll go over those answers tomorrow in class. So just to quickly review, if a line has a positive slope, that means it is going in an increasing direction from left to right. If it has a negative slope, then it looks like that. And then the most challenging one usually are the 0 and undefined slopes, and so determining the difference between the two. 0 slope is something like that, where you have a horizontal line. Okay, and we'll look at an example in just a minute so we can talk about how that has 0 slope. An undefined slope is a vertical line. Okay, so this line is straight up and down. And we'll look at some of those right here in just a moment. Okay, so graphing horizontal and vertical lines. Vertical lines are in the form x equals k, where k is some constant, and you could use any variable essentially to represent that constant. Some textbooks use a c, some textbooks use a k. And then a horizontal line is in the form y equals k, where k is a constant. So let's go ahead and try an example. If I have x equals 6, sometimes students have trouble differentiating between x equals and y equals lines. So for me, what I would do is kind of pick a couple of different points that you could graph to help you determine which way it is. So in this case, that means 6 is always going to be the x value. So you can pick any other value. Maybe you like -3. Then you have the 0.6 and maybe 0. Then you have maybe 6 and 2. And you could continue going on as long as 6 is the x value. And so this is our x coordinate. And so we have 6 in that position. All right, so let's go ahead and graph that. So that's 1, 2, 3, 4, 5, 6, and then down 3. So there's my first point, 6, -3. Then the next point I have is 6, 0. And then I have another point, 6, 2. And that's enough to use to go ahead and sketch my line. Okay, and then of course we'll go ahead and label that. Okay, and we can apply the same strategy for dealing with y equals equations or y equals lines. So in this case, y equals -4. So here you would have -4 as your y value. And you could try something else with -4 as your y value. And that means you can pick any x value you want. So maybe we'll start with -4. Okay, and then maybe we'll use a 1, and then maybe 3. And so now we can go ahead and plot those points. And so we'd have -4 and -4. And then I have the point 1, -4. And then I have the point 1, 2, 3, -4. So it gives me a few points, and then I can go ahead and sketch the graph of that line. To the recording area, you can go ahead and use a straight edge similar to what I just did. And then of course we'll go ahead and label y equals -4. Now, if we want to talk about the slopes of these, if I were to consider the slope of y equals -4 and we wanted to use that formula, we have change in y, -4 minus 4 minus -4 technically, over, let's say, 1 minus -4. So in the numerator, I have 0 over 5. And since I have a 0 in the numerator, it doesn't really matter what I have in the denominator. My overall answer will be 0. And that's why a 0 slope line looks like this. Versus the x equals, here I would have the 0 in the denominator. And when you have 0 in the denominator, you have undefined. So if you wanted to put a note for yourself, undefined slopes, that would be kind of like x equals lines. And then 0 slope would be y equals lines. So that's kind of a little extra piece of information. Okay, the last thing I want to talk about is parallel and perpendicular, just to review. Parallel lines have the same slope. So that's like slope of one of them is equal to the second. The symbol we use for parallel is just like that. And so a lot of times I think about that as an equal sign. So if you were to tilt it to its side, you'd see that's an equal sign. So that's kind of your hint for equal slopes. And since many of you took geometry, you use this as a symbol when you were doing Euclidean proofs. Okay, perpendicular lines, their slopes are negative reciprocals. And the symbol for perpendicular is like that. And we know that perpendicular lines form 90-degree angles, so that makes sense as a symbol for it. Okay, let's take a look at that last problem. Determine if the following slopes are parallel, perpendicular, or neither. Okay, so that means I'm going to go ahead and calculate the slope for first line 1, which contains these 2 points, and then the slope for line 2, which contains those 2 points. Okay, so the way that I'll do that is I'll show m of L1, so I'm differentiating similar to how you did your proofs last year if you took geometry. And I'm going to go ahead and label x1, y1, x2, y2, just to make my formula use a little easier. So I have 2 minus negative 3 over 4 minus 2. Okay, so I'll go ahead and calculate my slope, which would be 1 plus 3, and then 4 minus 2. And so my slope for this particular line is 2. Okay, then I'll go ahead and calculate the slope on the other line. So I have the slope of L2. And so again, if you want, you can label x1, y1, x2, y2. And so I have negative 2 minus negative 6 over negative 3 minus 5. So negative 2 plus 6 gives me a 4, and negative 3 and negative 5 gives me negative 8, or negative 1/2 if I reduce. And so now if I consider 2 and negative 1/2, those are negative reciprocals. So in this particular case, L1 is perpendicular to L2. Okay, I'll see you all tomorrow.